We propose a novel approach to predict human actions as well as human whole body motion and dynamics for a future time horizon for real-time applications. Starting from human dynamics and motor system theory, our approach is based on deep neural networks. In this work, we are addressing the two problems together: what action human will perform as a classification problem, how human motion will evolve as a regression problem. In the literature, an approach is to solve the two problems separately. Another approach is to solve action recognition first and then solve problem of motion prediction using a single neural network. Alternatively, we can have a single network to recognize the human action and multiple networks for prediction of motion, picked up by a selector, similarly to the idea of mixture of experts. Using the available techniques, the action and motion prediction problems are partially interconnected, and it's not clear how to deal with transient phases when human actions alter. To overcome those difficulties, we are presenting guided mixture of experts for solving the action and motion prediction problems simultaneously. Differently from conventional mixture of experts, in this architecture we have two outputs. The gate output predicts the human action, and the expert's output predict human motion and dynamics for a given time horizon in the future. We can write down the network loss function as the sum of the two loss functions related to action recognition and motion prediction, and solve them in a single optimization problem. In our framework, human motions are captured using IMU sensors that are distributed along the human body, and the ground reaction forces and torques are measured using I-field shoes. The pipeline is composed of two phases, offline and online. In the offline phase, an IK solver first computes human states with 66 degrees of freedom. Then human whole body states as well as the interaction ranges are visualized to a human expert for annotation. Later we train the guided mixture of experts network. In the online phase, the network receives the outputs of inverse kinematics and shoe data, enabling it to predict future human actions, motion and dynamics simultaneously. As we have shown in this video, the proposed architecture can effectively learn and predict human actions and motion. On the right side, the red avatar shows the prediction of human motion in 0.2 seconds in the future, while the gray one shows the current state of the human. We have modeled three different human actions, including walking, rotating, and standing, as shown on top left. In this experiment, the prediction has been done for 1 second of future time horizon. Finally, when human action alters, the results show the effectiveness of guided mixture of experts for predicting human motion and dynamics in transient phases. For more information, please check out our GitHub repository.